Okay, I thought I'd just do a quick video. Me pulse jets, just a random sort of a chat about where I'm at with them and some of the ideas that have been good and some of the ideas that have been a flop. So there goes. Well, the first thing is I've been doing pulse jets like most pulse jetters from a very young age. So I come over here and show you some of these that are just piling around in the shed. Got a Bailey one here looking a bit rusty. And these are all awesome on control line. That's the standard setup there. And this was one I made. These ones here. See the booster Venturis like they have in Holly carburetors or Weber carburetors. Now they work really good to vaporise the fuel, which meant I could have a much larger intake without having to have the Venturi restricting it like this one would do. That would restrict the airflow. So I was trying to get maximum power. Now Ilya Zanin said that's all good, but for pickup, like acceleration like in a car engine, but that's my whole point. It's when there's poor vacuum, that's when they work good. So I wanted a massive intake which would have a poor vacuum, but it would get a lot more air in. But what backfired on the whole plan was, what I didn't realise was, using alcohol and nitromethane, there's no need to flip and vaporise the fuel. You can literally just spray it straight in, and the engine actually had the maximum horsepower that way. You don't need to vaporise it. And the other factor is I was losing power of the shockwave that comes all the way to the front. By having such a big diameter here to fit all that in, I'm actually losing some of the kinetic energy from the shockwaves. And also it's wider, so it's more wind resistance when it's flying fast. But it was a very quick engine to start. You only had to face an air gun at the front hole there, just go ch-ch and bang, it just fired instantly. And it would draw all that fuel through, no worries at all. And as for the length of the head, I went for the 80mm head, which the guys in America in the past had always found was the best length. And that seemed to work too with this. So this one made 7 pound of thrust, which was a lot more than these standard ones. The sport jet setup, but they're a lot easier to build and pretty easy to deal with. So the other thing I wanted to try was a conic ring inside these, something I'll show you on the RC one. But although it made all the pipe red hot, as soon as I put it in, the thrust went down 1/2 pound. So, and then I even tried Louvers in it, but that still didn't solve it. So with the nitromethane, it's better off just washing down the walls, quite frankly, as in liquid form. It doesn't need to be vaporised and kept off the walls, and it just washes the walls and it fires off, and yeah, 7 pound thrust. Now the only one that's impressed me more really is one of these setups of a friend, Knowles and Eddie. He made one with a much bigger intake of course than that one, but same design, same reeds, didn't even go for a Bigfoot reeds, just the bigger backing plate. And he just jagged, you wouldn't believe it. I tried so many short heads to try to stay within Aussie rules for sport jet, and all of mine were duds. Even one as big as this that was just made much shorter, same design every way but shorter, it lost 15 mile an hour straight away without that extra length. Whereas Noel managed to fit his in within the 65mm, and the shape he just made, something just clicked. The tuning of it just came spot on and made 7 pound thrust, same as mine. So his fits the rules, mine doesn't. Mine had to go into the fast jet range where it really can't compete against the fast jets. Fast jets do actually have a smaller intake head, which can magnify the strength of its tuning, and Yeah, and like I said, there's no need for this big booster Venturi setup. It's all good fun. It makes this one easy to start. I don't even have to have anyone else start it for me. So I've got a little self-start system, and it would do 160 mile an hour. Wasn't too much drag with the design of the plane. But Noel's one actually went faster. His planes were slightly faster, and but the engine was the same thrust, but just a shorter head. And I hadn't come across any other head shorter that could make the same thrust as his for all the other, you know, dimensions that match. So, and that was the other thing too. His pipe was a Zanon Z27 pipe. It's just slightly bigger diameter along here, but it fits the Australian rules. So, anyway, this was my Zanon pulse jet, which I did a lot of experimenting with. It was made in Inconel. As he said, difficult to work with, and I think the vibration and everything, I had cracks form and had to have them re-welded over and over again. Perhaps wasn't such an ideal metal for a jet engine that vibrates like these do. This one here I had made out of just ordinary tubing from a shop that just, well, sells ordinary pipe tubing with its cone, and the tailpipe, you know, what was it, 53.5 mil or something, I can't remember, but I worked out this one actually did make the maximum horsepower figure capable for this tailpipe, which was 20 mil, and even went over that with my little afterburner stuck in the tail end, in theory, and that was on just a particular day. It wasn't every day. I went and tested it a few other times and it was down to 16 pound. So I was a bit dazzled by it, but it did in theory make full power one day, 20 pound, and then 22 with the afterburner. 20 was the maximum it should have made for that tailpipe diameter. But anyway, I moved on from the smaller size. I thought I'll keep everything else the same. I just go for a bigger diameter pipe. So it came off a car basically. It's exhaust pipe tubing for a car. It is in 304 stainless, whereas that was the other one. And that was 67 mil inside diameter, but it couldn't quite make the full power because the head wasn't big enough, I guess. Anyway, this is the Hubitz one made in Germany, and these were 90 mil. And standard when I got it, it was about 12 pound thrust, and then with working it with different reed valves and yeah, I managed to get the thrust up a little. I think I had 16 pound was the highest I ever had with an afterburner setup, and 14 without the afterburner. The 14 pound was good. When I crashed one of these on its first flight, I think it was 14.5 pound thrust on the day, and they're just on petrol and kerosene and things, feels like that. But this one here is my latest, and the whole point of the one of the main things of this is these louvers. You can see here where the fuel's been washing from this injector spray nozzle here, 0.6 mil hole in the centre. And I think it's only 2 mil diameter, but solid bar to spray sideways out of, right there. There's no reeds in it, obviously, they're over there. You can see there's not much to it, just anodised aluminium head, looks like a Bailey one. And the reeds, they're just blue spring steel. Not the best, but they're easier to get hold of and cheap. But the problem for me is when I put these holes in the centre, that's where they crack, and they split right across the start from the inside out. They're under a bit of load there. And these ones generally don't fail at all in this particular setup. So these ones are 8 thou, and these ones are 10 thou. So 10 thou cover the hole, and the 8 thou has to go over these then. And when this runs, the 8 thou opens first, lifts up first because it's lighter. The air pushes that one open. The air goes in between the two reeds, creates a vacuum actually. They always like to be close together. Anyway, because there's so much air now rushing in, there's about, I worked out, if I'm right, about 500 mils of mass of air, like half a litre of air per explosion. So that's a lot of air to yank in through these reed valves. So that one opens and the second one gets pulled open. They both open and wrap open together like that around the backing plate, and they're both shut together. It was a very good design. It helped stop chipping. I used to get chipping all around the outside of reeds with solid reeds, but with this double reed and the holes I don't anymore. It stopped the chipping. Also this base plate here, it's free to move and bounce. You know, the base plate is spring steel also. I think that was 10 thou, and the reeds bang against that, and if they break they don't damage the aluminium faceplate bit. It's protected by that, and it seemed to be a good shock absorber. This plate is free to sort of bounce up and down, absorb the shock, and that helps stop the chipping also, as does the fuel washing across here and spraying all around, getting them wet. I leave a little bit of 2-stroke oil in it for the pump to lubricate the pump, and it helps cushion the fall, I guess, of that. So the next part was the flame holder, and the flame holders are used quite a bit around Europe. Stop the engines conking out in the air on full throttle, and just to get them to maximum power. Without that, they start great, they start quick, but as soon as your throttle goes up, the fuel washes against the sidewall, runs down, and without mixing with the air, and it reboils off, but it was causing the engines to run erratic, and the engine would even come to a stop. So by having this flame holder in here, the flame can sit behind and help ignite everything. The engines then run smooth. But my thought was you might be losing power, because a return vacuum wave up the pipe will get trapped behind there and only end up bouncing back the other way, therefore we've lost the energy. So I put these louvers in here, and the vacuum wave can then break through, pass its energy through, and add to the suction at the front end here to open reeds, get more air in, and it seemed to work. And it also did something else. When the blast goes off, the blast goes in behind and then shoots out of these back on an angle and helps to choke the intake, working a bit like a Tesla one-way valve, and that helped protect the reeds from the flame. And it definitely did, it definitely worked. So that was another bonus. At least I think that's what it's doing. It seems to work great anyway. If I just drill holes in it like I had for my Hubert's one, the flames come through and still tend to burn the reeds. Well, it still made the full power, but the reeds tend to be prone to overheating. So this way here, it worked the best. And the other thing it does is, because this fuel goes sideways, it doesn't all mix in the air and just go straight in. A lot of it will just come straight across and collide with the sidewall here, especially when the reeds are shut and in operation, and then the fuel washes up this wall here, goes over the top, and this being all really hot, it just reboils it quickly and mixes it with the air. And some of the questions I got is the blast that's coming back through there actually the hot flames? Because it doesn't seem to get that hot on the edge anymore. It seems to be cooler along this section. And I'm wondering if it's actually the fuel's gone over and the incoming air's gone over and it's swirled around under, and then maybe even the blast has pushed it back up through here and around again. So it actually could be starting a vortex, and which might be a good thing. Vortex ring inside here might postpone the ignition, or it might just be keeping the naked flames away from the front. So I don't really know. It's just, I'm only guessing as to how it works so well, but it does, believe me. And the spark plug in the side wall here gets the fuel straight away. As soon as you turn the fuel spray on, it just hits it and bang, we have ignition straight away. So it's a very tiny spark plug. Don't know if you can see it very well. It's off a RC model aeroplane from America, that one. And for startup, it's very important to have these reeds flicker. They, if you haven't pressed back too hard, or if the gap's too big, if they've got a bend in them and there's a big 1 mil gap or bigger, then the engine just pops and bangs and you just can't get it to run. But when the reeds are just down at the very edge, just, you know, not pressing hard against it, and the leaf blower's blowing, these can get a nice easy flicker going, and that works with the sound waves coming up and down the pipe. Then you might call it resonating. Then once the flickering begins, and then within seconds you can just fire them up. They just jump into action, no sweat. Then that's a big part of it, that resonance or whatever. So here's the thing. Here's how they're supposed to work. When the explosion goes off, there's supposedly, according to even old German literature and videos, there are two things created in the explosion. There is a vacuum wave that starts heading this direction, because this is all to do with sound. It's just like super grunty sound waves, and sound is energy. It's not actually displacing of anything, it's just running through it, you know, like waves on the ocean, tsunami waves. When you throw a rock on the ocean, it's just, that's all it is. So a vacuum wave heads that way, a pressure wave heads that way, regardless of the main explosion. That's the sound shock wave that just gets sent off down here. Now the shock wave sent this way is a pressure one. It's under high pressure and it's very narrow. And it's got to go through gases that are on the move down here very fast. The expanding gases that are moving, that are doing the pushing, it's got to go through them. Comes hooting down the end here. When it gets here, the pressure wave then like dumps sideways. It's trying its hardest from a sideways point of view. It can't do that till it gets here. As soon as it lets go sideways, it then creates, there's a vacuum created momentarily, and the vacuum then races back this way. Half the energy is gone in that direction. The sound comes off at about 45-degree angle here with a real strong sort of a note. When you put your head here at 45, you can really hear it coming off. So anyway, the vacuum wave then goes back the other way through all that exploding gases that are coming out. The vacuum wave, as it creeps up through here, you got to remember this is coming out like, I'm guessing, 700 kilometres an hour. The vacuum wave coming back the other way at the speed of sound's got to get through that, so it takes time. It's much slower coming back this way than it is going that way. And as the vacuum wave is coming back, it's also getting wider, wider, wider. Now, how wide it gets, I don't really know.